I'm Anil Kumar, and in this video we will understand how to find solution of a polynomial function. So let me begin with taking an example. So let f of x be equal to a polynomial function which is let us say x cubed minus 4x times x plus 3, right? So let's take a simple example. So this is a polynomial, x cubed minus 4x times x plus 3. This polynomial is given to you and you need to find solution of this polynomial. Now how to go about and what does it really mean? When we say find solution in general, let me say in general, right? In general, find solution means that f of x is equal to 0. That is what it means if it is not specified anything, right? That is what it means. So in general it means find the value of x when f of x is equals to 0, right? So its find solution means f of x equals to 0, find x. Okay, so that means for what value of x is the function 0, right? So what we can do here is we can equate 0 for f of x, right? Now this equation can be further factored. Let me factor it to find the solution. We can take x is common, so we'll have x squared minus 4 times x plus 3. And this is difference of squares, so we could factor that also. We get x times x plus 2 times x minus 2 times x plus 3, right? So that is how we can actually write down the equation in completely or fully factored form. Now, when will this be equal to 0? It could be 0 for any of these factors to be 0. Is that okay? So that gives us number of solutions. The first will be when x is 0, right? So it is x equals to 0. The second one will be when x plus 2 is 0. So we can write x plus 2 equals to 0. That means x is equals to minus 2. The third one could be when x minus 2 is 0. So we can write x minus 2 equals to 0. That means x equals to 2. And then we also have a solution when the third factor, rather the fourth factor, x plus 3 equals to 0. So that is when x is equals to minus 3. So what we note here is that we have 4 solutions. Is it okay? We have 4 solutions in this case, and they are at x equals to, we have 0, plus and minus 2, and minus 3. So let me write them in order. Minus 3, minus 2, 0, and 2. So there are 4 solutions for this given polynomial. Well, this is a degree 4 polynomial where all these solutions are linear zeros, right? So there are these 4 solutions. Now that is one way of looking into it. Now another way is that sometimes you may be given a graph, right? So let me sketch a graph here for you, and then we'll discuss the solution of a polynomial from a graph. So let us say that the polynomial is kind of like this. So we'll just sketch one here, turns like this. Let's say it goes from here, and then it is. So I've again taken another degree 4 polynomial. It has a couple of turning points, as you can see, and so these are the turning points, 3 turning points in this case, and we have many zeros. One of this 0 here is, let us say, at x equals to minus 2, and let's say this 0, which is not at origin, let us say this 0 is at let's say 1 over 4. So let me write this as 1 over 4, and then we have a 0 here, and let us say this 0 is at let's say 1.5. Okay. Now when I say find the solution from the graph, now in this particular graph always x the independent variable will be along the x-axis, and the function f of x or y is along the y-axis, right? That's the 0. Now from the graph, if you have to read the solution, you're looking for x-intercepts, correct? So solution from graph. That means you need to read x-intercepts. Correct. So if you read x-intercepts directly, you know the solution. So you know the solution here is x equals to minus 2. Then we have x equals to 1 over 4. And we have a solution which is 1.5 or 3 over 2, right? So these are the three solutions which you can read from the graph itself. Now, in this discussion, what we have assumed so far is that the solution is when the value of the function is 0, right? That is in general true. Now, at times, you may have functions where we are looking for some other value. For example, let me sketch another graph here now, and then I'll explain you what I'm trying to say. Let us say that we have a graph, in this case, kind of like this. Okay, so that's the graph. Now, first question is, let me call this function as f of x. Okay, now for this function, how many solutions does it have in general, right? So in general, we have f of x. So how many solutions it has? So you'll say there is one solution since there is one x-intercept, right? So we say one x-intercept, one solution, right? Okay. Let's write down a few numbers here. Let's say this turning point is at x equals to minus 1, y equals to, let's say 1. This turning point, let's say, is at 2. And this intercept, or the turning point, let it be at 3 for easy calculation, right? And let's say this turning point is at 2.5. Okay, so we have this kind of a graph. Now the question for you is that for what value of x can, let's say, for what value of function f of x can we have, let us say, 3 solutions. Right, so try to understand the question. The question here is, this is very important. For what value of x, for what value of function f of x, can we have 3 solutions? Now we know this one solution, let me draw a line here, is when f of x equals to 0, right? Then you have only one solution because that's the value. F of x is 0 means x-intercept. Is it okay? X is wherever it crosses the x-axis. Now the question is, for what value of f of x can we have 3 solutions, right? So you may like to answer this question. And similarly, we could have another question which says, write possible values of f of x so that we can have 2 solutions. Okay, so these are the 2 questions for you, right? Let's say question A and question B. You can now pause the video, answer these questions. For what value, the first one, for what value of f of x can we have 3 solutions? And then write possible values of f of x so that we can have 2 solutions. Okay, let's understand the concept. Now, if I draw a horizontal line, for example, if I draw a horizontal line kind of like this horizontal line intersects the graph at 2 points. Do you see that? So for f of x equals to 3, we'll have two solutions. Do you see that? So that gives you two solutions. That gives you two solutions. Similarly, if I draw a line here at the turning point, again, for f of x equals to 2, how many solutions do I have? Two solutions, right? Do you see that? So these are the two solutions. When I talk about solutions, we are writing the x values. Is that okay? So this x value is the solution for f of x equals to 2. Okay. Now for 3, similarly, you can draw horizontal lines where it could intersect at 3 points. So if I draw a line between 2.5 and 3, somewhere here, as you can see, it will intersect at 3 points. So we have 3 solutions. So we can say for f of x equals to 2.75, for example, right? I could have drawn a line here. So there are many values of f of x which will result into 3 solutions when f of x is equals to, let us say, between 1 and 2, right? So which is, let's say, 1.5. The solutions are the x values for which f of x is 1.5. There are 3 such x values. You can see that. Is it okay? There are 3 such x values. So they become the solution. I hope you are understanding the concept here. So in general, when we say find the solution of any equation, we are assuming y to be 0 or f of x equals to 0. Okay? That is in general. And the solution is represented by x-intercepts. Is it okay? But we could have had different number of solutions by having different values of f of x. For example, in this case, we are trying to say for what values of x can f of x has a value of 3. So if we say 3, then there are 2 values of x. That means for f of x equals to 3, we have 2 different solutions, right? So for the same functions, we could have many different solutions. Is it okay? Now, getting back to the original question where we started from, f of x equals to x cubed minus 4x times x plus 3. When we say find the solutions of this equation, then we are saying that find x-intercepts, assuming f of x equals to 0. And clearly, we got 4 different solutions as shown here. Now, we could say that for what value of f of x, can we have just 2 solutions, right? For what value of f of x can we have just 2 solutions? Correct? So if you know this point, we can easily find the value of f of x. In this case, if I write the question, for what value of f of x do we have 2 solutions? We know the end behavior is kind of going downwards. So for any value which is very large negative for f of x, we'll have 2 solutions. Do you see that? So on the safe side, we could always say that, right? So we could say that f of x equals to, let's say, negative 1000. So of course, it'll be like far below, kind of like this. So we'll have 2 solutions since the graph will intersect f of x equals to minus 1000 at 2 different places. So f of x equals to minus 1000 will have 2 solutions. I hope you are understanding the concept. If I would have drawn this graph on a graph paper with a proper scale, you could have answered this question in many different ways, right? So I'd like you to explore this concept and understand, sketch few graphs to the scale, and then find for what values of f of x can we have 1 solution, 2 solution, 3 solution, 4 solution, or even no solution. Is that okay? So you could do that as an exercise. And this is a very important concept, and I hope that will help you in many tests, especially for advanced SAT. I'm Anil Kumar. You can always share and subscribe my videos to understand. Thank you and all the best.